Hello students, today we will continue with our last topic that we have started in lecture 3, that was types of matrices. Now we will move forward. In the last lecture we have studied about row matrix, column matrix, square matrix and diagonal matrix. 4 types we have studied. Now the fifth type is scalar matrix. Now what is scalar matrix? A diagonal matrix, that means scalar matrix must be a diagonal matrix, is said to be a scalar matrix if its diagonal elements are equal, right? So in the diagonal matrix we have seen that all the diagonal position should be non-zero and the non-diagonal position must be 0. So scalar matrix, in the diagonal position all the elements must be equal. So for diagonal we must have that matrix as a square matrix. So in general we can write it as a square matrix. B is equals to Bij. Capital B denotes the matrix, small bij denotes the entries or the elements. M cross M, because the number of row and number of column for a square matrix are equal, is said to be a scalar matrix if Bij, that is the entry at the Bij element, ith row, jth column, if position of row and column are not same, right, then it is equal to 0. And if the position is equal, that is number of position of row is equals to position of column, then it is equal to some constant, any constant it could be. We have put here small k. Suppose in an example you can be clear. Suppose we take an example as matrix A. Suppose we take it as 2 cross 2 matrix, right? 2 cross 2 means 2 row and 2 column. Suppose we take here 3 0 0 3. So this is the diagonal position, right? And non-diagonal are 0 element, so it is a diagonal matrix and the diagonal elements are same, that is 3. So this is called a scalar matrix, right? So in the similar manner we can make a 3 cross 3 matrix also. Suppose we take 7 7 0 0 0 7 0 0 0 7, right? So this is also a scalar matrix, diagonal matrix. Diagonal elements are same and non-diagonal elements are 0 and all the diagonal elements are equal to 7. So this is an example of scalar matrix. So very simple it is. Now we will move to the other sixth part, which is very important type of matrix, that is called identity matrix, right? So identity matrix is what? Identity means, we know that identity we denote it by 1. So what is for matrix, what is the identity, right? So a square matrix, it must be a square matrix, that is the number of row equal to number of column, in which elements in the diagonal are all 1. Means all the diagonal elements must be 1 and rest are all 0. That means all the non-diagonal element, that the elements which are not present at the diagonal position are 0, is called as an identity matrix, right? So in other words, square matrix, A is equals to Aij. Capital A denote the matrix, small aij denote the elements or entries in the matrix, n cross n, that means it is a square, so number of row equal to number of column, is an identity matrix if Aij, the position of the elements, is equal to 1 if I is equals to j, 0 if I is equals to I not equals to j. That means if position of row element is equals to position of column, for that case we must get 1. So we used to denote identity element by capital I, right? And we used to write here small letter. In suppose we have 3 cross 3 matrix, so we will write here I3. Now I3 will be what? This will be 1 0 0 0 1 0 0 0 1. You can see that all the diagonal positions are non-zero. So this is a diagonal element, square matrix also, diagonal matrix also, and identity, because all the diagonal elements are equal to 1 and its order is 3 cross 3 because it is having 3 row and 3 column. So it will be denoted by I3, right? Similarly we can write I2. I2 means it is of order 2 cross 2, 2 row and 2 column, and we know that the diagonal elements must be equal to 1. So 1, 0, 0, 1. Right. I1, that means 1 row and 1 column only, so it will be denoted as only 1. So in this manner you can make identity matrix of any order. Right. Now we will move to the next and last type of matrix, that is called a zero matrix. Zero means, as we can, it is the most simplest type of matrix. A matrix is said to be a zero matrix or null matrix. Null means also zero, that is nothing is there, if all its elements are zero. Right. So it is not written that whether it must be a square matrix or a rectangular. So any matrix in which all the elements are zero are said to be a zero matrix. Right. So we used to denote it as capital 0 is equals to, suppose we have 0 0 0 0 0 0. This is zero matrix example. It is having 2 row and 3 columns. Similarly we can write O is equals to only single element 0. This is also zero matrix. Suppose we write here 0 0 0 0 0 0 0 0 0. This is also zero matrix. That means the condition is that all the elements must be equal to 0. Right. So it could be a square matrix or maybe a rectangular matrix. Now the last topic for today. Now we will study that equality of matrices. That two matrices, suppose we have two matrices A and B. Suppose we have denoted the elements of A as small aij and elements of B as small bij are said to be equal, right, if they are of the same order. That means if matrix A is of order, suppose 2 cross 2, then B must be of order 2 cross 2, right? So these two matrices must be of the same order, first condition. And second condition tells us that each element of A is equal to the corresponding element of B. Right, that means position Aij must be equal to Bij for all ij. Right, if we consider, suppose we take an example, suppose we take a matrix A as equals to 2, 3, 5, 4, right, and matrix B, suppose we take it as 2, 3, 5, 4, right. So we can see that 2 here, 2 here, 3, 3, 4, 4, 5, 5 and 4, 4. So that means therefore matrix A is equals to matrix B. But suppose we take another example, we take another matrix, suppose C, we take it as 2, 3, 5, 4, right, same elements we take. Suppose this is A also. Suppose same matrix we have considered A, and suppose we take here C, we take here 3, 2, 5 and 4. Now we can see that this position 2, this is first row first column, right? So first row first column position is 2, but here the element of first row first column is 3. So this element, these two matrices are not equal to each other. That is, matrix A is not equal to matrix C. So that means for two matrices to be equal, all the corresponding elements must be same and their order must be same. Then only the two matrices will be equal. Right. So in the next lecture we will start with the questions of the exercise. Thank you.